absolutely delighted and thrilled to be with you this afternoon. My name is Phil T. I'm listed as the CEO of Moogsoft. In fact, I had a funny experience coming into the conference. I was on a plane, and as you often do, you have your laptop open, and I guess the guy sat next to me was looking over my shoulder as I went through all of the deep trade secrets of Moogsoft and shared all of that with him. And he said, "Oh, you with Moogsoft?" And I said, yeah, I am. He said, "How long have you been with them?" I said, "Well, long enough to say that I unblocked the first toilets of the company," which is, I think, how you define being a founder. But then he goes a little bit further than that. He said, "Oh, so you're exhibiting, are you then, at reInvent?" And I said, "Well, yes, of course we were exhibiting at reInvent. It's a super important show. Amazon and AWS is an incredibly important go-to-market partner for the company." And he kind of looked at me and he said, "So how big's your booth?" Which I thought was a very personal question to be sort of confronted with as I'm thinking through the week. And of course, you don't want to sort of sound like you're underestimating it. So, I think I probably made it up and said, I don't know, 40 by 40 or something. Something like that. He looked at me and said, "Oh, the $250,000 group." So, but there you have it. But anyway, it's fantastic to be here. What I'm going to talk to you about is we've been on a journey at Moogsoft really since we founded the company 8 years ago, back in London, as you can tell from the extreme East Bay accent. I may not be originally from these parts. But the journey that we've been on has been really pioneering the use of AI in the whole of the service assurance use case. Now, service assurance has been around ever since there's been a service to assure, and digital services are, of course, all the vogue. But this last 10 years, I guess, to the point today where I was very lucky on Tuesday evening to spend an hour or two with a group of CIOs of very large enterprises, where each and every one of them is saying within 5 years, north of 50% of our workload is going to be resident in the cloud. You can tell that there is a seismic tectonic shift occurring. And we believe very passionately at Moogsoft that AI is a critical component in how you deal with the complexity that comes part and parcel of that transformation. And specifically the thing we're going to talk about today, because we began our journey really very much focused on faults and incidents, is what happens when you introduce metrics into that recipe. And our belief is this culmination of AI metrics and logs is where we all need to be thinking. So let's take a little bit of a canter through history from the early 1980s. And one thing you must all get hold of from reInvent is the songbook, because the music is awesome. And it was, of course, particularly awesome in the 1980s when I was just young and out of college. So back then, we were really dealing with, in terms of digital infrastructure, a very different environment. It was really the mainframe era still. Most businesses, the core of their digital infrastructure ran on mainframes from IBM or Amdahl or similar. And if you were worried about really the sort of the service assurance and the quality of the service, I've kind of got bad news for everybody who thinks that the future is all progress. Actually, it was pretty good with mainframes. Very, very, very defined environment, very static. You could really sort of wrap your hands around what it is and plan for it. It was all highly integrated, single vendor stacks, low event rates, low change rate. Things started to really, as you transition through the 80s, and my first success as an entrepreneur with Micromuse was really dealing with the fact that distributed computing, client server, started to become part of, and particularly Unix, began to become part of the mix there. And things started to get more complicated. You were dealing with much more flexible infrastructures, distributed, lots of different vendors involved, lots of different standards. Everybody tried to standardize. The only real standard in there was the IP network that linked it all together. And you ended up having to sort of try and sort of pull this together in one single platform, which is what we did at Micromuse. And then you fast forward to today, And things really started to change when virtualization became a wave. And VMware introduced our customers to having to deal with hardware and the existence of a compute unit being physically separate, all the way to today, where containerization, microservices, instances that spin up and die in a heartbeat is very much part and parcel of the new compute infrastructure. And the software-defined everything world is incredibly changeable, incredibly difficult to pin down in terms of its configuration, produces a lot of data, billions of metrics and logs and events, and you're expected to try and maintain service around that. I personally am both sort of excited to try and solve that problem and fearful about where it's all heading, because there is an avalanche of complexity out there which we have got to collectively tame. And so you kind of look at that and go, so did the world go mad if it was kind of better in the mainframe sort of environment? And did we sort of invent all of this technology for the sake of inventing technology? By the way, that does happen. And was it a retrograde movement to sort of slightly parody the Douglas Adams, if you're a fan, Hitchhiker's Guide to the Galaxy? Are some of us beginning to think that coming down from the trees was a mistake? Well, the truth of it is form follows function in tech. And the global digital transformation is really what is driving the adoption of all this technology. Now, I don't know about you, but I live my life in the digital world. I bank with Bank of America, and to offend anybody, if there's somebody from Wells Fargo or other in the room, I have never, ever, ever been into a physical branch of Bank of America. And I remember opening my first bank account. You had to sit down with the bank manager and explain that you were a reliable individual. And that is just one example of how, in the digitally transformed world, very traditional businesses like banks are having to become digitally transformed software companies, frankly, where they are then simultaneously vulnerable to innovators. So fintech has serially disrupted a lot of our financial customers at Moogsoft, but also able to nip out and take advantages of new ways of doing business and intermediating with your customers. So this digital transformation, whether it's Uber, Bank of America, my doctor is even digital these days, what that is demanding this intensely agile and very flexible and short cycle time innovation for applications that are pushed out into the user world. And, just to spend a tiny bit of time really sort of double-clicking on it, just have a think about how many times today the digital world has touched you in that regard. Whether it's waking up like I did today to listen to the news on my mobile phone. Does anybody have a radio anymore? And why? Because, I'm British and we've got this little thing of a general election next Thursday. It appears that we have one every other year now. So we're all gripped to find out what's going to occur. Whether it's paying my hotel bill with an American Express card cleared through one of our customers, actually, Fiserv First Data, and Amex is also a customer. The Uber that took me from the Venetian to here, which you call using your mobile phone. We do everything. The rise in internet dating. We were always getting to the point where how you sort of do that very human thing of find a significant other, settle down, have a life. Maybe you do it more than once. You do that increasingly digitally. I read somewhere that they reckon that by the midpoint of the next decade, well over 2/3 of people will find that significant other through some form of dating app, which I think is kind of crazy. It does worry me that we may all eventually lose the ability to be social, but it is very much a part of how we will be. So if that's the backdrop to how we're going to lead our lives, just think about that as well. Because the consumer is intensely demanding, I was brought up in a corner shop, and I can tell you the general public is intensely demanding. They will expect all of that to happen with zero downtime and instantly, right? You know, it's got to be high response times, zero latency, fully available all of the time. And so you need to do that against the backdrop of constant change, an environment that is amazingly complex and changing, second to second. You know, when I first started programming a long time ago, you know, and you see all the various different languages that you have to learn, pretty much every book from O'Reilly starts with how you use this, that, and the other language to make hello world appear on a screen, right? So, you know, when you're learning C, you do the hashtag #stdio and int main printf, right? You know, Java, fairly similar, Rust, whatever, all these different languages. And in the cloud world, you know, to make hello world appear inside of your microservice, you have layer after layer after layer of Docker, Kubernetes, the instance itself. The world has just gotten a lot more complex, which is probably why the evidence of systematic failure, so the poorer quality of service, is so evident out there. Whether, you know, it's, I don't know, is anybody here a British Airways customer? I mean, I am, I kind of have to be. British, all that kind of stuff. I mean, they've had a series of significant outages. And it's not them, they're not alone. You pick up the news, you see all of these large-scale infrastructures kind of creaking. Whether it's large or small enterprise, the primary canary in the coal mine to detect service-threatening outages in nearly 3/4 of the time, I think it's a Forrester stat, is actually the end user, the person that you are trying to deliver that service for. You know, very famously in the monitoring world, you know, we do spend quite a bit of time coaching our customers with this. You know, the technology is one part of it, but, you know, deploying it, the people, the process that goes around it, is also super important as well, which is why you hear ubiquitously, we've deployed all this monitoring, and yet we still miss stuff, despite all of that data. That stat there, again, I think is out of Forrester or a 451 report. 66% of monitoring solutions, you know, identify less than half of the instances that are out there. And you kind of scratch your head and you go, why is that the case? Why is it historically so ineffective at surfacing all of those incidents that you need to be on top of? And if you look at the oldest adage in infrastructure and application monitoring is, you know, things don't break, people break things. With all of that change going on, all of that automated change, you know, this growing complexity is leading to tons and tons of outages. So we're left in this paradoxical situation where, as things get more complicated, the tolerance for error reduces down and down. It turns out that at greater scale, we actually have less visibility. So, what to do? Now, the sort of the personal journey, as I kind of indicated before, for me, goes back 25-ish years, 27 years maybe, to back when I co-founded Micromuse and wrote a product called Netcool, which I don't know if whether that makes any difference to anybody anymore. And these were all in the rules-based era. And so here's the idea behind a rules-based monitoring system. What you do is you take your infrastructure and you analyze it. You think, how can it possibly break? What failure modes are there that I need to worry about? So, I don't know, it could be a disk runs out of space, so a database is going to crash. So what alerts, I hypothesize to say, what alerts will that failure produce? And then what you do is you write rules to detect the presence of those alerts in the monitored data that you're pulling up and prompt the action in some sort of automated way. So the system and the measurement, in some sense, are separate. The system is kind of assumed to be the thing that you do monitoring to, and it is something which you can consider as separate from the monitoring, and it is something which is, by implication, static. The problem with that approach, and this is really at the root cause of why a lot of these poor results are being obtained in the much more sort of cloud-native, voluble, change-heavy environments. The problem with that is these rules are extremely rigid. The scalability of these systems tends to be fairly low. And paradoxically, because when we started Moogsoft and we started telling people that we wanted to use AI to do operations, they kind of thought we were crazy. And paradoxically, they're actually guilty of the one thing that AI tends to get accused of, which is they can be very indeterminate. Like, I can break a netcall implementation really easily by changing the order of arrival of alerts. That will kill a rules-based correlation engine. So what we believe, what we've conceived of, what the wave at Moogsoft is all about, is AI as a way out of this. This is really where you combine effectively the state, the system, and the measurement in one place. Because you're not having to statically analyze the infrastructure. You're allowing the data that it produces, the events and the logs that it produces, to fundamentally define the patterns and the failure modes for you in real time. Sounds pretty cool. And fundamentally, also, when we started out, most people didn't believe us that it worked. Because what they were missing was you have to layer, and I'll get into this a little bit later, many different layers of AI, starting with information theory, going through unsupervised machine learning into supervised machine learning to achieve the ability to be separated or at least disconnected to the configuration of the system that is underpinning that. What we've spent a lot of time on, and again, I'll point that out as we get in, is making the AI algorithms scale to be fluid and capable of dealing with the event rates that you find, and I'll get into that in some gory detail in a moment, that you tend to find in the enterprise, large and small. Because pretty much if you go download, I don't know, a Python machine learning library, most of the algorithms are somewhat designed and constructed to be used in, I guess, what I would describe as a batch mode, statically analyzed fixed sets of data. And obviously, in a monitoring context, you have to do that in a streaming way. And so an awful lot of time was spent at Moogsoft to allow that to be the case. Take it on advisement from me that we have fixed that problem. And if you want to get the show me version of that, of course, please visit our booth and we'll demonstrate it to you. But once you have that, you're able to have this kind of very fluid sort of data drives features that we extract, drives the actions. And what we've been able to really prove out through the course of Moogsoft's journey is that leads to the ability for us to be able to both consume the volume of data from an event perspective, but also use that to drive the extraction of real-time instance and catch things, recall, as we would say in a machine learning context. So the what to do, our fundamental reason for existence, if you like, is you put AI into the core of how you do operations. And of course, this is now, 8 years later, it's a market category. So if you wander around the hall up in the Venetian, there are many, many vendors talking about something called AIOps, okay? And in fact, again, not this is going to sound like an endless plug for our booth, drop by and meet Will Capelli, who works for us, used to be at Gartner. He actually coined the term AIOps back when he was an industry analyst. I don't know whether there's, as you read that, that term AIOps, the one thing that is fundamentally wrong with it. Anybody know? There's no such thing as AI. So this is one of these sort of, the way in which the human language gets conflated. Artificial intelligence. And we had quite an incredible talk by a lady called Flynn Coleman, who's just written a book, The Human Algorithm, which talks all about this. It is incredibly difficult to even define what intelligence is, and if you can't measure it or quantify it, how can you build a computer to replicate it? When we mean AI, just for the avoidance of doubt, because I have been picked up on this occasionally when we've spoken, what we really mean is machine learning. Okay, the ability to spot patterns in data. But I said I was really mostly here to talk about monitoring. So why don't we talk about monitoring? So the interesting thing, and traditionally for Moogsoft, we started at the logs piece in this. And what I wanted to really sort of point out in this is the volume curve, and there's no science, by the way, in this. It's a drawn line. What you see with metrics, what's different about metrics to events and alerts is really a volume and information density difference. So, typically if you are monitoring an at-scale environment, it's not unusual to get thousands of events, log messages a second. And that same environment will quite happily produce 100,000 metrics a second to kind of give you a sort of a view of the scale. So the first thing to say about metrics is there's a lot of it out there. And actually, most componentry of digital infrastructure is perfectly capable of producing vast amounts of metric time series data. Given that we're in an AWS conference, just go scroll through CloudWatch and look and see how many different things it can tell you. It can tell you tens of thousands of things. Okay? But we would argue that the problem with that is that this phrase information density is low. So the existence of a time series stat telling you that the CPU on a server is 94.3%, for argument's sake, actually tells you very little about whether that is something which you need to worry about, not worry about, jump out of a window about, be ultimately relaxed about. It's not really giving you the context and a prompt for you to do anything. You need to know a lot more. Like a great place to start is, okay, so if it's 94.3% or whatever the number is I made up, what was it like yesterday? What was it like when he was doing something different? Do I have one of those servers, or is it part of a 1,000-server web farm that I'm using to serve my latest dating app out to all of my customers who are desperate for love? Aren't we all? So you need to take, metrics are a raw piece of data. And actually what we find, and what we are arguing, is that in their rawest form, it's kind of really just like a comfort blanket. So pulling a load of metrics, shoving them on a graph, having yourself a dashboard, it looks great, and we've got all of that. But in and of itself, what is it actually telling you? And you could argue the same about raw logs, right? I mean, our dear friends at Splunk made a hugely valuable business out of the job of spelunking through logs by adding search, because an individual log message is not particularly interesting. So we see this continuum of data from metrics at very high volume, and ultimately what you need to extract from that at a much lower volume are the underlying incidents that you need to be able to surface to guarantee service. So in reality, it's a matryoshka doll, or one of these kind of these things, these stacking Russian dolls. I was corrected by one of our Moldovan team members when I said it's a Russian doll. She said, no, it's a matryoshka doll. So the idea is actually these things roll up. So metrics, what you want to surface from them is an anomaly. When is this value something that I need to care about, and how do I extract from it and the associated logs an alert being a point-in-time notification of the change of status of a something, and then correlate those alerts into a, do you know what, we have an incident that you need to go deal with. So really the whole point of this is service quality, right? So we are trying to sort of combine the metrics management with alert management, with AI for correlation, AI for anomaly detection, to give you a better handle on what the true state of your digital infrastructure is. So what you want to do is use, harvest the context of the logs, take the traces, the metrics, and use that to diagnose any instance. Make sure you fix the right instance in a timely fashion, and then maybe what you can do is learn from that as you cycle through it. One of the key challenges, though, is it's a fairly cheesy way of putting it, but performance is from Mars, faults are from Venus. I don't know if you'd be able to get away with that book in the modern environment. Men are from Mars, women are from Venus. How sexist is that? But the truth of the matter is they are very, very different. If you think of the data rates, they're completely different. Really, it's not the value of an individual time series metric that is important. It's the value in the context of the entire data space. And whereas with an alert, it's a single isolated thing that you're going to go do, a fault, and what you need to worry about is how you action that. Typically, when you are dealing with metrics, you're really buried in the component tree. It tends to start very, very low level. Even if it's APM, you are looking at an individual virtual machine, Java virtual machine, or a Python process, or whatever the various different applications you've written, or the tools you've written your applications in. And so it's buried in that, and it doesn't have really function and context as part of it. And that's not good, right? Because ultimately, confronted with that data, how are you going to turn that into something you can make sense of? Which is really where observability really comes into the picture here, and why we think that AI generates observability from metrics. What you want is you want an underlying app to publish to you perfectly contextualized metrics. So instead of saying the CPU is 93.6% or 94.3%, what you want it to tell you is the CPU is normally high, and you want to generate from that perfect root causes. The application will know all of this because this is the world of observability. The engineer will have designed for observability so that the right incident on time all the time is kind of an out-of-the-box experience. It seems pretty straightforward, right? In fact, you might even say it's elementary, dear Watson. Who knows what the connection is between the Cottingley Fairies and Sherlock Holmes? No. So effectively, Conan Doyle, as well as being the author of Sherlock Holmes, was a bit of a leading late Victorian whack job. He was into everything. He used to go to seances. He believed in ghosts, the paranormal. I mean, he was absolutely right in the thick of this thing. You know, you have with that, he creates this character Sherlock Holmes who is totally the opposite to him. You know, completely, essentially lives in a cold, logical world. So I don't know whether he was working this out. So the Cottingley Fairies were a late Victorian scam, actually. It turns out. So the picture there is I believe it's Conan Doyle's niece or something. And these fairies are absolutely airbrushed onto the photo. This is kind of an early example of a deep fake that took Victorian Britain by storm, actually. The Cottingley Fairies were believed to be incontrovertible evidence of the existence of fairies. And Conan Doyle was completely sucked in by this and was a leading proponent that this was evidence of it. So anyway, so it's elementary, dear Watson, right? It's easy. And here it is. The difference between what we have and what we need is algorithmics. And, you know, I, in some senses, find it almost astonishing when we first started getting into building metrics into our platform, the degree to which the statistical analysis of metric data is kind of stuck in the Stone Age. And, you know, people were really still, you know, setting manual thresholds on values and doing it on almost a metric by metric, source by source basis. And the first thing that we wanted to do is apply the algorithmics that have been so successful for us in the fault world to metrics as a way to turning that raw material into something useful that we can use. So AIOps produces a new manifesto for observability, and here it is, very straightforward, 3 points, elementary. The first thing that we're going to do is we're going to push AI to the edge. Machine learning is capable of doing wonderful things to understand the context of one data point in terms of another. And at Moogsoft, what we've done with our Express product is built into an agent or a metric collector, it can work in both modes, the ability to build live models of metrics to show you when you have a meaningful deviation, both on an individual metric and on an aggregated basis, that can serve to produce an anomaly and ship up with it what we call an envelope of the relevant data outside of that. Honestly, we're just getting going. In our labs back in London and in San Francisco, we have all manner of algorithms under development using techniques as diverse as long-term, short-term memory, and also topological data analysis to extract out of the time series data even deeper meaning. But we shove all of that stuff out to the edge so that you're not shipping into a data lake a vast amount, because it is a vast amount, of metric data and hoping that you can run queries and searches and this, that, and the other all over it to pull stuff out that's of interest. Save the supervised stuff for the aggregated layer. So root cause and actionability. Remember I said all this business of layering the AI. The supervised stuff, use that for root cause, use that for determining actionability and assisting the actionability. So AI at the edge, unsupervised in the middle, supervised in the center. And replace this data lake with this robotized response. The fully automated quality anomaly drives automated actions. And, you know, there we are with no apologies to Brian Ferry. You automate away the heartache. That's our manifesto. And to give you a blueprint architecture for this, and this more or less is effectively It's somewhat vendor agnostic. There are other people. The idea is you make sure you bring into a single platform your metrics, your logs, your alerts, notifications. With the AI at the edge so that these metrics are turned into meaningful anomalies. You want to have deep neural nets, you want to have AI, you want to throw all of the capabilities of machine learning at it to get extremely high quality, actionable incidents. You want to plug that into closed loop automation so that with quality instance you can drive automated remediation. We have customers, incidentally, by the way, that have automated away their entire L0 function by doing this. And from that, you can continuously accrete an inferred runbook, which you dump that into whatever the system of record is for both incidents and also for these runbooks. The other term you'll see quite a lot around Moogsoft is continuous assurance, because fundamentally that is where we are heading. So AIOps is the path to continuous assurance, the path to being able to make sure that there is 100% availability on that dating app that I just made reference to. So in summary of that agenda, don't celebrate, it's not quite the end of the talk yet. We believe that observability without AIOps is just noise. We think if you go and you just generate metrics, just like logs really fundamentally are the end result of some debug message being put into code, what you're going to end up with is just an overload of nonsense. And it will lead to all of that 66% of monitoring isn't used, 74% of instances being reported by users. We believe that observability with AIOps is this fast route to continuous assurance with closed loop automation. And the ultimate holy grail of self-healing. So I want to talk a little bit about Moogsoft and dive a little bit more into what it looks like from a product perspective. I got asked by a bank. They have these analysts that run around. So this AIOps stuff is pretty exciting, Phil. How can I, and everybody's talking about it, who's lying was the subtext of the conversation. Who's really doing AIOps and who's just rebranding a bit of old technology and hoping that it works? He said, how would you tell? I said, two things. Go and ask them how many patents a quarter they file. Not how many patents they've filed, how many patents a quarter. Because this space, from almost a pure research perspective, is red hot. There are discoveries being made on a day-to-day basis. There are things that you need to do. If there really are an AIOps company, they will be investing, they will have a science group that is investing in the technology that underpins all of that. At Moogsoft, we're a little over 50 patents filed, 20 granted. Everything else in the middle of the patent office stuff. As it happens, Moogsoft also participates in and funds primary research. So we have postdocs and PhD students and all kinds of fun stuff all over there helping us with these things so that you don't have to do the data science. We do the data science for you. As a business, we're 8 years old. We're very well capitalized. Goldman Sachs, Redpoint Wing, all of the, these are all Sand Hill Road VCs, super duper people, helping us serve our customers. If you look around our team, so, we have collected together some really incredibly experienced people who are both very, very deep in the domain of service assurance, but also deep in the domain of machine learning. And we've got a purpose-built platform in its 7th generation going to its 8th generation. Multiple product, well, in fact, actually, they're repackaging, so they're multiple offers. And we can point today to 130 odd of the Fortune 2000 as customers of Moogsoft, where they're deploying the product at scale, and I'll show you a few of the names in a mo, across many, many verticals. What it looks like today is an aggregation layer for metrics, alerts, logs that is distributable. Those consist of agents that you run either on your on-premise infrastructure, if you are doing on-premise type things, or agents that you put into your cloud. We pull all of that into the center. In our cloud offering, which is a SaaS service, it's where we run all of the AI and the machine learning to surface all of those notifications. And then we have a very wide range of horizontal integrations into Jira, Slack, other IRC tools, problem management tools, whether it's ServiceNow, Cherwell, Remedy, all of that fun stuff. And the idea is that what we've built with Moogsoft is this system of engagement for observability with it. So I said there's there are a lot of algorithms in Moog. And in fact, actually, they cover an extraordinarily wide range of areas. So kind of working left to right. When you ingest, whether it's metrics or logs, the huge amount of data that you pull in, most of it's junk. And the first job of any platform is to rid the core algorithmics from the junk. So in times gone by, the way in which you would have done that is you would have done a manual process of blacklisting and whitelisting, which is obviously extremely time-consuming, error-prone, very rigid, and so on and so forth. What we do at Moogsoft is we have adapted information theory to measure the informational content of an individual log message, anomaly, whatever it is. How do we do that? Well, what we do is we build on top of a dictionary. For those of you who are into this kind of thing, it's a term document dictionary, an inverted index. So if we have a piece of text, like, I don't know, rhinoplasty is a fairly unusual word. If you saw rhinoplasty in a log message, it's an unusual thing to receive. It's got a higher information content. So we do this assessment of the information content of the log message at that level. And then we allow the user of the system to tune, using a graphical tool, where to set a bandpass filter for information. And what we generally find is that about 1% of the ingested data is responsible for over 80% of the actual service impacting issues that you will find. So it's enormously useful. Then we go into the feature detection algorithms that use unsupervised machine learning. So we can work on time. So what we mean by that is looking across the entire data set of anomalies, logs, metrics, all that kind of stuff. Looking to see where there are non-trivial sort of co-occurrences of things. And we use a series of techniques that range, if you're a data science nerd, from a convolution for similarities, is where you're sort of measuring the overlap of things, which we then turn into a graph, and then we use tools of modularity to decompose that graph into its individual modules. And these are nodes in the graph that are more connected to each other than they are connected to stuff out there. And it allows us to determine these non-trivial co-occurrences. And the fun thing about that is it's a clustering technique. And if you know anything about clustering, so k-means, for example, the k in k-means is how many clusters would you like today? And you can take an arbitrary data set and you can split it into as many clusters up to the number of items in the data set. Our algorithm here actually determines along the way the optimal number of clusters. Fairly similar again with language. We're doing similarity, language decomposition. In fact, that's a lexical similarity. Coming out next year will be a semantic similarity. So the difference being, cat and mat are very close to each other lexically, but extremely far apart from each other from a semantic perspective. We'll be able to work that through for you. Topology, it tends to be the case that faults and incidents propagate through an infrastructure. So actually, interconnectedness can help scope things down. Then we have this fun concept called vertex entropy. And the entropy in that is measuring the information in the structure of a dependency graph. So if you imagine whether it's a network topology or a service topology or anything else, it's which of the nodes in there are important. Usually the example that I give of this is slightly off color. But if you wanted, for example, to bring the London Underground or the New York subway to a halt, which station do you take out to do that? And, I'm more familiar with the London Underground, if I'm honest, than the New York subway, so you'll forgive me if I stick with that. It turns out that most people would say Piccadilly Circus, but it turns out that Earl's Court is just as good. And you learn that by understanding this business of node importance. And what we did at Moogsoft with vertex entropy, and by the way, this is primary research that we did, was we found out a way to calculate this node importance without a full dependence upon the entire topology map. It's pretty neat. And the algorithms that generally have been used before to attack this are very non-scalable, whereas vertex entropy really is. Then we have an algorithmic correlation engine, which uses streaming and clustering to put together alerts and anomalies into prototype instance. We have the concept of feedback. So we look, and this is where we get into the supervised machine learning, we look to see how people transact incidents. And as they transact incidents, we learn hints as to which correlations were more operationally significant than others, and speed those up, prioritize those up. And then the last thing is, as part of the operation of the system, we can identify also from operator behavior where the probable root cause of an incident was, and we train a deep neural net to figure that together. So each one of these areas in the Moogsoft product is the subject of patents, the subject of usually some primary research that we've been involved in. And actually, coming up very soon on our website is a research area where you'll be able to go and dig in and see some of the breadth of what it is that we touch at Moogsoft that has generated these different approaches to AIOps. We're a vigorous bunch. So we are, we're not done. And, as we continue to innovate, my expectation is that slide will get a lot busier over the course of the next year or two. At a board meeting about 2 years ago, we got into this kind of discussion about what is our unique value proposition at Moogsoft. And one of our board directors very waggishly said, well, you know what, actually it really boils down to our stuff actually works. Which is, why today there are, leading Fortune 1000 customers across very many different verticals that are heavily dependent upon our software. And we're hugely proud of our user community. Actually, we just got back at the end of October from our inaugural user conference in Chicago. And at our booth, we've had customers presenting alongside our prepared content as well. So that concludes the stuff that I wanted to take you all through as a set of content. We have 10 minutes, which is kind of what I was solving for at the end of the talk, and I'd be delighted. I don't know if there is a capability to take questions, but would be delighted to answer any questions that anybody has before we end our session. Really interesting question, that one. And fundamentally, that's what the entropy stuff is doing. And actually, and there's, I think, a number of dimensions to that question as well. So, yeah, do you have to clean the data before you can take advantage of AIOps? So first up, there's a lot of data, and you have to strip out the noise. We measure the noise using entropy. That is very effective at doing that. But there's another dimension to it as well, because we deal with unstructured data an awful lot in terms of service assurance. And you don't want to have to go through the process of structuring that data quite so much. And historically, how we tackled that at Moogsoft is by providing off-the-shelf cleaners, if you like, for that data. Actually, we're bringing out as part of the Express package in March of next year when it goes in GA, an automated structuring algo. And that actually uses about 4 different types of neural nets buried in there to try and automatically deduce the syntax of the unstructured data. The reason why you want to do it is ultimately at the end of the day, you're going to present that data to some form of machine learning algorithm. And pretty much any data scientist who's done it for longer than 10 minutes will tell you, the most difficult thing about data science is actually feature engineering and making sure that you are presenting the data in a way that is most adept at the algorithms to pull it out. But we do a lot of that behind the scenes. It's all kind of baked into the technology. Yeah. Mm-hmm. Did everybody get the question? If you've got an existing application and you want to work with the metrics of it, do you have to understand the application and the metrics, or can you get? So this is the other reason why we think that AIOps has to be pushed to the edge with metrics, because you're quite right. If you think you're over-instrumented from a log message perspective, you're really over-instrumented from a metrics perspective, and it's all about what's important. As it happens, the way in which we ingest metrics, first up, we don't have to be the primary collector of the metric. This is not another agent to go measure CPU utilization. We can plug into StatsD, CollectD, Kafka, and whatever you're doing to agglomerate all your metrics, we can collect it from there. But what the agent does, you can put it in discover mode. And so what it will do is it will learn the data patterns from the metrics, and it takes approximately 2,000 data points for you to have a really high accuracy. I mean, if anybody's done stats, as a rough rule of thumb, your error is 1 over the square root of the data size, more or less. So about 2,000, you're getting into pretty accurate. And it'll learn the data pattern of every individual metric. And most of the metrics will be really boring. Things like, I don't know, if you dig into some of the agents you'll find on networking devices, you'll be collecting the number of ports that a switch has. Well, guess what? That never changes. Why is that in there? But you want to be able to sort of eliminate out all of that stuff which is invariant and unnecessary. So we believe that is a key challenge, and that is part of the reason why we spent such a lot of time making our agent intelligent to be able to do that. Totally. So the question, for if anybody didn't hear, was how do you kind of encourage developers to engineer observability for machine learning? So that they're not just throwing junk data and kind of triggering the rubbish in, rubbish out thing, and what are the challenges involved in doing that. So first up, I think that it's an obvious statement maybe, but data science is still a relatively rare skill in the developer cohort, and although increasingly today, if you look at the kind of the intake and the way in which university courses are structured in computer science, increasingly informatics and data science is forming a good chunk of that, and so it should. And I think over the course of maybe one generation of new entrant engineers, that will rectify itself, all very well and good. I think the truth of the matter is that you can take one of two paths to this. One path is you try and be prescriptive and encourage the developers to tag stuff. I think sort of giving some kind of hint as to what is the context of this data item that I'm spitting out is always going to make the job upstream a little bit easier. Or the other approach that you can take is to sort of accept that developers are going to be their glorious, unstructured, uncivilized, chaotic selves, and put the burden on the ISV, on us, to make sense of it. And if I'm honest, I don't think we can wait for the first approach to bear fruit. I think the burden is on us, and we absolutely spend a lot of time trying to do that job. It boils down to the previous question, really, of structuring that data for the user. But the truth of the matter is it is an issue, but it's an issue that is shared regardless of the approach that you're taking to try and do observability or monitoring. I just think that we may be in, paradoxically, a slightly better position to engineer our way around it. And whilst all of that is doing, just keep encouraging, the kids to study math. I kind of get slightly irritated by the proliferation of teach your kids to code. Have you seen that? It's like, come on, guys, teach your kids to love maths, right? The coding comes. Yeah. So the question there, if you didn't hear, is with AIOps, are humans going to get eliminated in the operations thing? No, I think they'll be doing a different job. And in some senses, it's the identical issue with AI everywhere in industry and in the world. That there is a natural belief that this is going to threaten a task that is currently done by a human. I actually think what it does is it elevates humans up. And if any of you have had a job in operations, I've done it. It's a very high pressure, very repetitive process of acknowledgement and sort of incident sort of handling. I think that the computer will increasingly do that, and the role of operations will shift much more into more of a business analyst, and trying to tag it back to the core mission of the business. In much the same way that in testing, we now talk about SDETs in our development environment, which is the software development for testing. So these are engineers that engineer high quality QA. It's an elevation of skills. And I think above and beyond that as well, AI can only get you so far. There is also an incredibly human part of operations. Back to that dating website, when it goes wrong, what I'm never going to be able to replace is the ability to offer, personal customer support to the disappointed, amorous customer. I think we've got 30 seconds, so I have to be quick. Mm-hmm. Yeah. it's part of our product to do the primary feature engineering of the logs, the metrics that we get, and make it easy or easier for people to do that. And it's an issue. And it kind of boils down to the raw data. And you can stick with the raw data. It's just I don't think you'll get much insight from it. So unfortunately, we can maybe take it offline or take it to the booth. So I think I'm probably going to get kicked off the stage. That thing's flashing red. So thank you all for listening, and enjoy the rest of the show.